Section 10.1 is simplifying square roots. So, what is a radical? A radical is an expression written with a radical symbol. So you can see that here. That is called a radical. You probably more commonly think of it as the square root sign. So what is the radicand? The radicand is the number under the square root sign. So 25 is our radicand. And we call this a radical because of the radical sign. So in the notes, it says square roots are written with a radical symbol. The number inside the radical is called the radicand. So example 1, find the square root of 52. Round your answer to the nearest tenth. So we can just plug this in our calculator. The square root of 52 looks like this. So we can go here. We get our square root button right here. So since it's in blue, we hit second and then this button. And now we can type in 52. If we round to the nearest tenth, that's one decimal place. So this is 7.2. Check your answer is reasonable. Well, we know, so if we think of perfect squares, we know that the square root of 64 is 8, and we know that the square root of 49 is 7, so square root of 52 falls in between those. So yes, it makes sense that it's 7.2 because that's right between 7 and 8. So my answer is reasonable. Use the Pythagorean theorem to find the length of the hypotenuse to the nearest tenth. So we know the Pythagorean theorem is hypotenuse squared equals leg squared plus leg squared. So in this case, our hypotenuse is across from the 90-degree angle, and that is C. So here's my two legs, square root of 2 and the square root of 3. So A is the square root of 2 squared plus B is the square root of 3. Okay, so we're taking B, which is the square root of 3, and then we're squaring it. So square root and squared are inverse operations. So those undo each other, which means this is just 2. And the square root of 3 squared is just 3. Now, if you're unsure, you can type that in your calculator. You can type in the square root of 2 squared, but they're inverse operations, so they undo each other. So C squared equals 5. Again, since they're inverse operations, to undo this squared here, I'm going to square root. So if I do it to one side, I have to keep my equation balanced and do it to the other side. So C equals the square root of 5. It says find the length of the hypotenuse to the nearest tenth. So we can type in the square root of 5 in our calculator, and we get 2.2. The 3 keeps this as a 2. So C equals 2.2. Let's do another one. This time, they gave us the hypotenuse. So we know hypotenuse squared equals leg squared plus leg squared. So my hypotenuse now, so my C value is the square root of 65. But don't forget, we still have to square C. And then that equals leg squared plus leg squared. So that's going to equal my A value, which say is 7 squared, plus my B value is X, so X squared. So again, square root is 60, the square root and the square root undo each other. So this just means this is 65. And then 7 squared is 49 plus X squared. I want to isolate my variable, so I'm going to subtract 49 from both sides, and that gives me 16 equals X squared. Now we want to undo the squared on the X, so I'm going to take the square root of both sides, and the square root of 16 is 4, because that's a perfect square. So you could type that in your calculator if you were not able to recognize that. So here's a property of radicals. When we multiply the square root of A times the square root of B, we can just put them under the same radical and multiply them. So this is called the product property of radicals. So for example, square root of 3 times the square root of 7, I can just do 3 times 7 under the same radical, and that's the square root of 21. Now, I can't simplify this because 21 only has prime factors of 7 and 3. So To make sure that this is fully simplified, we're going to make a factor tree. Okay, any two things that multiply to 21. Well, 7 and 3. These are both prime. So there's no perfect square factors that go into 21, so I know that it's fully simplified. And I'll talk about that a little bit more in the next slide as well. So again, square root of 2 times square root of 8, we can just multiply 2 times 8 under the same radical to get 16. And 16 is a perfect square factor because it's 4 times 4. So the square root of 16 is 4. If you're unsure, you can plug that in your calculator as well, and you'll see that it's 4. Now, what if we have this number, the negative 3, on the outside? Okay, we can keep the negative 3 on the outside, and then we can take the square root of 3 times the square root of 6 and just put the 3 times the 6 under the same radical. So we have the negative 3 on the outside times the square root of 18. Now, 18 is not fully simplified because there's a perfect square factor that goes into 18. So what I want you guys to do, so over here, this was simplified because the only two numbers that went into 21 were prime, and this was a perfect square factor. But you're always going to have to simplify if possible, which means, does a perfect square factor go into 18? Well, what are my perfect square factors? That's one way to do it. I'm going to have you guys make a prime factorization tree in order to simplify radicals. So just come up with any two things that multiply to 18. I'm going to guess a couple of you are going to say 9 times 2. And then break 9 down. What two things multiply to 19? Or what two things multiply to 9? That would be 3 times 3. Now, we broke 9 down, so I'm just going to cross it out. This is called the prime factor tree because I have a 3, and a 2 on the end of my branches, and those are prime factors. What I want to do with the prime factors is I want to try to make couples. So here's a pair of 3s, so I'll call it a couple. Now, couples go out once. So I'm going to put a 3 here because it's a couple. So think of like couples go out to one restaurant. And then we have a 2 left over. So if they're single, singles stay in. So we leave the 2 under the square root. And then we still have this negative 3 on the outside here. So what operation is happening here? That's multiplication because they're right next to each other. So that means that if I have any two numbers on the outside, I need to multiply them. Okay, you're never going to add in a plus sign because there is no plus sign in the problem. So negative 3 times 3 is negative 9 times the square root of 2, and that is my most simplified answer. So I like to think of it as outside numbers and inside numbers. Okay, negative 3 is on the outside, and then there's just a 1 on the outside here. So 1 times negative 3 is negative 3 on the outside. And then we have square root of 2 times the square root of 2. Now those are both on the inside, so I can multiply them both on the inside. Well, square root of 2 times the square root of 2, well, 2 times 2 is 4. So we have negative 3 times the square root of 4. Well, what is the square root of 4? That's a perfect square factor because 2 times 2 is 4. So the square root of 4 is just 2. So what do I do with the negative 3 and the 2? We're going to multiply them because they're right next to each other, and that's multiplication. So negative 3 times 2 is negative 6. Is it okay that there's nothing left in the radical? Yes. It just simplifies to negative 6, which is fine. So now let's multiply these, which means I can put them under the same radical. That's the square root of 12. Well, I know that the square root of 12 has a perfect square factor of 4, right? 12 can be broken down to 4 times 3. So we're just simplifying the radical here. And then what two things multiply to 4? 2 times 2. So I'm going to cross off the 4 because we broke that down even further. And then the 2, and the 3 are my prime factors because they're on the end of my branches. So once we get there, we want to look for couples. So here's a couple, and couples go out to one restaurant. Okay, so I just put a 2 on the outside of my radical. And then we have a single 3 here, which means he has to stay under the square root sign. So the square root of 12 simplifies to 2 square root of 3. Now, there is another way that we can think of this. We just used a prime factor tree to simplify radicals. There is another way that we can think about simplifying radicals. And that is by looking for perfect square factors. Now, what makes something a perfect square? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on. So if our radical isn't simplified, it's going to have a perfect square factor. So for example, 12 has a perfect square factor of 4. So 4 times 3, I can just rewrite 12 as 4 times 3. Now, what is the square root of 4? That's just 2. And then 3 is prime, so 3 stays on the inside. Now, if you make a factor tree, you're going to get the same thing. 4 times 3, 4 breaks down to 2 times 2, and we have a couple. If couples go out to one restaurant, and singles have to stay in, so we get the same thing, 2 square root of 3. Okay. So you can do either method. Square root of 45. Well, 9 is a perfect square factor that goes into 45. And we know that the square root of 9 is 3. And 5 is not a perfect square, so 5 stays under the radical. Now, if you made a factor tree, you would get the same thing. Okay, 45, we could say 9 times 5. 9 breaks down to 3 times 3, and now I have 3, 3, and 5 on the bottom of my branches, so those are all prime factors. So I'm just going to cross out the 9 because we broke that down even further, just so you can see the ends of your branch. So now we have a couple, and that couple goes out to one restaurant, and then we have a single, which is this 5, so 5 has to stay under the square root sign, and we get the same thing. So just 2 different methods, 2 different ways to think about simplifying radicals. We're going to do a couple more examples. Square root of 24. Okay, I'm going to do the factor tree. I'm just going to think of any 2 things that multiplied 24. I thought of 6 times 4. Well, 4 can get broken down to 2 times 2. 6 can get broken down to 3 times 2. So if you have a couple or a pair, they go out to dinner once, and then here's a single 2, and here's a single 3. So both the 3 and the 2 have to stay under the radical sign. And since they're both under the radical sign, we're going to multiply them to get 6. So this square root of 24 simplifies to 2 square root of 6. Okay. 36 is a perfect square factor because 6 times 6. So since the square root of 36, since 36 is a perfect square factor, we know that the square root of 36 is 6. Square root of 125. 25 is a perfect square factor. We know 25 times 5. Let's break this 25 down to 5 times 5. So now you can see we have a pair. So couples go out to one restaurant. Singles stay in. So they stay under the radical. And that is our most simplified answer. Why did we not use the 25? Because we broke that down even further. Okay, so you can kind of cross it off. So I only use the 5, 5, and the 5 on the bottom of my branches because those are my prime factors. One more that I want to add in because we're going to see this later in the chapter. Actually, I'm not going to have you guys worry about that. We're not going to do these types of problems. I'm going to take those out. So don't worry about rationalizing the denominator.